Today we're going to continue talking about line integrals, and in particular we're talking about the analog of the fundamental theorem of calculus. So the first thing to point out is that when we're doing line integrals, the actual curve we integrate along makes a big difference. So if we've got two different paths that go through the same vector field, even if they start and end at the same position, they might give very, very different total values. So for example, for this vector field at the left here, we start at one point and end at another. If we go along this path from left to right that I've drawn here, the vector field is very, very small, or maybe even at zero along the points along those lines. And so there's very, very little energy transfer. Whereas by contrast, I could take a different path from the same start to the same end that zips up, goes over, and goes back down. Then it's moving through a part of the vector field that pushes very, very strongly to the right, and it gains a lot of energy from the vector field. Or I could go around through the bottom, and then I'm fighting against the vector field when I go along the bottom line. So we get very, very different amounts of energy transfer depending on which path we choose. Or uh, a slightly different example is this one at the right, where if we go along a clockwise curve or a counterclockwise curve, we get different energy levels because one direction is going in the direction of the spiral and another is going away from the spiral. So we get different line integrals depending on which way we go. But there are a lot of important vector fields that have a physical interpretation that have like a conservation of energy law. What we're going to be talking about today, they're called conservative vector fields. One important example is gravitation. Gravity has a conservation of energy law. And for those, the line integral only depends on where we start and where we end. We can't cheat and follow a different path and somehow get more energy than we would have if we kept on a straight line one. And so those kinds of vector fields are very, very special, and they're going to be the topic of today. One particular example is that in a conservative vector field, we're going to have the property that if we do a line integral around a loop, we're going to start and end at the same position, and whatever we gain along this loop is going to be nullified by the fact that we're going back to where we started. So we're going to get a line integral of 0. And one way to think about that is that instead of a loop starting and ending at the same position, we could say, okay, we've got these two paths, number 1 and number 2 here. They both start and end at the same position. So this line integral on top is going to be the same as this line integral on the bottom. This line integral at the left is the difference between the top one and the bottom one. And so the integral around the loop is going to give us 0. So that's a special property of what are called conservative vector fields.